Welcome everyone to the post-contest discussion of Leetcode Weekly Contest 361. I'll explain all the 4 questions. Okay, let's start with the first question. First question, in the first question we have to count the symmetric integers. Now, what's a symmetric integer? If there is a digit of even length, that is twice n length, means even length only. It is called symmetric if the sum of the first n digits is equal to the sum of the later n digits. Means if we have a digit like 1111, we can see here if we separate it in between, the sum of these digits is equal to the sum of these digits. If we do this 2 3 and 3 1, you can also see that here also the sum of this part is equal to this part. Okay, we just have to calculate that only how many integers from low to high are there that like contains that is a sum of the first n digit is equal to sum of later n digits. Okay, the question is easy with the constant tend to 4 only. If we just calculate the sum of the n digits, it will take like log of 10 of n operation, like log of 10 of n operations for each digit maximum. Like if we take this number, there will be only like 4 operations. There will be only 4 operations. We just have to do 3 plus 1 and another 3 plus 1. That is like 4 operations. So that was the time. If we iterate through all the numbers from low to high and calculate the sum for each number, the time complexity will be log n into log 10 of n. So what I have done exactly in that in the code. I am iterating from low to high for each number. I'm checking if the sum of the first half is equal to the sum of the second half. At first, I'm checking if the number is odd. If the number is odd, there is no possibility because the number should contain 2 into n digits. The odd numbers do not contain that. So I'm doing sum for the first half, that is s dot length divided by 2, because here the length is 4 and it is the sum will be from 3 to 1 only. Then I'm subtracting the sum from the latter half, and if the sum is equal to 0, still equal to 0, it will return 1, or if sum is something else then 0. If this part is greater, the sum will be negative. If this part is greater, sum will be positive, so then it will return 0. This was a fairly easy question. Then let us move to the second question. Okay, in the second question, we are given a string num representing a non-negative integer. In one operation, we can pick any digit of the number and we can delete that digit. And at the end, we have to check if the remaining digit, like after remaining number after deleting the digits, is divisible by 25. Like let us see a number 44545. This is a number. If we or no, 4545 if we delete this last 5, we have to delete this 5 because if we keep this 5, it will not be divisible by 5 like it is not possible to make it divisible by 25. Let us delete this 5, last 5. The number will be 4540. Now we can delete this 0 or delete this 4 or any digit. Like if we delete this 4, the number will be 454. If we delete the 4, the number will be 454. Then again 4 and 5. And at last we will contain, like after deleting every digit, the digit will, the number will not contain any digit, and that is always divisible by 25. It says if you delete all the digits from the number becomes 0, and 0 is always divisible by any number. So if we delete all the n digits, the answer will be always possible. That means the maximum answer can be n. Like if we delete all the digits from the string, the answer will be uh, the maximum answer will be n, and it will be divisible by 5. But we have to calculate the minimum number of operations. If we do or delete all the digits, it will take the maximum number of operations n, and that will be divisible by 5 only. Now let us notice something. We have to make it divisible by 5, okay, 25 only. How can we check if a number is divisible by 25 or not? Okay, it is a simple like or not like rule. If a number contains 500, like 00 at the last at the end of the like the end two digits are 00, then it is divisible by 25. If the number contains 25 as the last digit, then it is also divisible by 25. Divisible, yes, yes. If the number contains 75 or the last two numbers, it is divisible by 25. If the number contains 350, 50 at the last two digits, then the number is divisible by 25. Always, number will be always divisible by 25. Yes, but if the number contains something like 751, it will be not be divisible by 25 because it contains 51 at the last two numbers. So we have to make the string like that only. It just have to contain one of these forms. Like it should contains either 00 at the last of the string, like last of the at the last, or it should contain 25, or it should contain 75, or it should contain 50. One of uh, these possibilities will be fine to make the number divisible by 25. Now, how we will find a minimum number of operations from this? Okay, let us see for this question. You can see there is 50 here, so I have to make the string like I want to make the string like that. It's like that only, that at the end two characters will be 50 or 20 in one of these forms. But here it contains 50. So I will just delete these two digits, and this number will be divisible by 25 only. So the number of operations is 2 because I deleted 4 and 7. In this question also, like there is a 00, like 00. I can from this type, like this type. This there is 00. I will delete this 5. I will delete this 3 and this 8. The answer will be 2900. For this question, like if the number contains 0, only 0, the number will be divisible by 25 also, because 0 is always divisible by something. So I'll just delete 1. So now for the solution, how will like form the solution? Like we have to find the minimum number of operations to make the string like last two digits like this. How can you form like make this last two digits like this? Okay, let us see some string 5 to something like that. This string. Okay, here you can see I have to delete like if I want to make 50, I want to make 50 like this because all other possibilities are nil. We have to delete this all these indexes and all this, like the answer will be 5 plus 4. Hmm. Now let's say if I give an 1 and 0 here. Now I can make this either 50 or 00. Now let's check which will be minimum. For the if I want to make this string 50, like 50, then I have to delete this all these characters, that is 5, plus I have to delete all these characters for 4. The operations will be 9. If I want to make like 00, last two digits 00, so I don't care about the numbers before that 0 only. I don't care about those numbers. I care about these numbers that is between 00, like both zeros. That will be like how many? This is 5, and after 00, there will be 5 only. Answer will be 10. Now let us introduce another character here. Let us introduce another 5 here. Okay, 5 here. Now we can check for 25 also. If I check for this 5, if I have a 2 here, I have a 2 here. So the answer will be I have to just delete this one. I can delete this 2. The answer will be 25, but it will be always get the 25. So see, the answer will be these two characters plus this one character. Answer will be 3. So the final answer is answer will be if I check for I will check for 5. If I five character 5, I will I'll check how many numbers are before after it. I don't care how many numbers are before 2 and how many numbers are between 2 and 5. If I check for 25, if I check for 50, I'll check how many numbers are before after 0 and how many numbers are between 5 and 0. If I check for 00, if I'll check for how many numbers are after 0 and how many numbers are between 00. Okay, that is what I have done in the implementation. Okay, I have taken a map of positions. The position will store the latest position of all the characters. Okay, now checking for 0. I am taking the last character. Currently, last character is 0. Like this. So the other possibilities, the before character will be 5 or 0. Okay, I have to calculate how many characters are after 0, how many characters are between 5 and 0. Like you can say here, if there exists 5 in the map, like I have encountered 5 before, the answer will be how many characters after this. That will be n minus I minus 1. And how many characters are between 5 and 0. This will be the position of 5, position of 5, position of 5 minus position of 0, like this. Because if I subtract these two, the answer will be I'll get the number of characters between this. Again, I have checked for 0 0. I'll delete all the characters from after this 0 and between this 0. The answer will be the number of characters between these two zeros and after the 0. And the same for this 5. I'll check for 5. There are two possibilities for 5. If the last character is 5, the before character between 2 and 7, the answer will be same. How many characters are after 5? How many characters are between 2 and 5? And at the last, I have taken this edge case. if the number contains only a single zero, answer will be if I number contains something like this, 1 2 1 2 5 0 sorry 5 1 2 3 0. I can delete all these characters and then string will be 0 and the answer will be n minus 1 on uh, it is divisible by 25. So I'll delete n minus 1 characters if the string contains a single 0, only one single 0. I'll take the minimum of all the answers I got before here. The answer maximum answer can be n. I've taken initialized answer equal to n. Then I'll check possible answers from here. And at the last, I also check the possible answer. If the string contains a single 0, then answer can be n minus 1. I'll take minimum from this all the possibilities. And that is the solution from for the second question. I hope there is no doubt. Okay. Okay. Let's go for the third question. Okay. In third question, we are given a string, array. We have to count an interesting subarrays. And what does a interesting subarray means? Okay, an interesting subarray means that the count of nums if I have 3, I have modulo 2. I have to count how many subarrays are there. The count of 1, count of 3 mod 2 equal to 1 is equal to k, and count modulo is also should be also k. Okay, just to simplify the question, let's see an observation. Okay, like I have some array like 5, 6, 7, 8, 9, 10, 11. Okay, let's consider modulo is 2 and k is like I'll later see about k. Okay, I have to check if nums of I modulo m equal to k. Let's k equal to 1. Let's see k equal to 1. And count of I'll later say about count. Okay. Here 5 is satisfying this condition. 6 is satisfying this condition. Not satisfying. 7 is satisfying this condition. 9 is satisfying this condition, and 11 is satisfying this condition. Now the latter condition is I have to count the number of subarrays such that the count of this like indexes like this are this modulo m is also k. That means I have to take count of 5, 7, 9, and 11. I don't care about 6, 8, and 10. So one thing you can observe this, the number 5, if I mod it, it will be 1. Okay, so the whole number 5 does not matter. The mod of this number also only matters. So I'll initially take the mod of this number only, like 1, 0, 1, 0, 1, 0, 1. Okay, now this condition, like I have to count how many subarrays are there such that count of k mod m is also k. Like I can completely ignore this condition now. I'll just mod the whole array like I have done here, and I will count how many integers are there in the array that is equal to k, and the count mod m equal to also k. Like if I say I can take this length of the string, 1 length or 3 length of the, because 3 mod 2 is 1, 3 mod 2 equal to 1, and 1 mod 2 equal to 1 also. I can also this string because there are 3 ones, and I can also I cannot take this because 2 ones. I can also take this one. So I just want to find out the count of ones, the case in the array, and from that I have to figure out how many are there such that count mod m equal to k. Now let's go. For that, how many subarrays are there such that count mod m equal to k? One thing we can do is like I'll count how many like let's see that I have count 1, 2, 3, 4, 5, 6. Like just check for this question, this array. Let's just count 1, 0, 1, 0, 1, 0, 1. The array has become like this. Now I'll count how many ones are there. There is 1, 1, no increase in 1. There is 2, 1, no increase in 1. 2, 0, 2. Sorry, here it will be 3. As I'm just taking the number of count, I'm taking the count of ones, like a prefix sum. There is 1, 1. There is like I'm counting the ones, like prefix sum. How many ones are there till that index? Okay. Now I want to find out how many subarrays are there such that count mod m equal to k. That is 3 minus like count mod m equal to like if I have 3, I can check like I can take this subarray. I can take this subarray. Not this subarray. Sorry, this subarray. I can take this two subarray because they're count of that is always like odd, like odd, that is mod equal to 1. Because here m is 2 and count k is 1. Like now how will calculate the number of like subarrays? One thing you can notice, if I know this like if I know like the sum till here, this sum of like the fixed sum here is x. If I know how many are there, like if there exists x minus k also, like if there exists x minus k also, that subarray can be included in the answer, because here exists 3. If I just take 3 minus k is 1, 3 minus 1 2, that subarray can be included in the answer, because like 3 minus x minus 1, 3 and this you can include from here k also, to k minus k also fine. You can include all this from here. Here it will be 4 only. You can include 4 minus 1, that will be 4 minus 1, k is 1, for sum is 4, 4 minus 1 3. Okay, you can include all this, because the count of the subarrays is equal to 3 only here. You can include these 3. Sorry, you cannot include this 3. You can include these 3, and you can include these 2 only. 3 minus 1 is 2. 3 minus 1 is 2. Okay. So it is indicating there are 2 ones in here. Why it is indicating there are 2 ones in here? 1 and 2, because there should be 3. 4 minus 1 0, it should be 0 here. 0 1 0 1 1. Here it should be 2. Here it should be 1 2. So I'm decreasing 1 1 next, because here it should be count should be 2. That means 4 minus 2 would be 2, and here should be count should be here count should be 3. That means 4 minus 1 is equal to 3. Okay. Now we can see that the number of I just have to count if there is exists x minus k and there exists x, the answer will be that subarray can be included in the answer. Now let us mod this also. 0 1 1 2 2 1, sorry, 0 1 0 0 1 0. Now I just have to count how many if there exist, like there exist, how many exist, that count of this 0. I have to make count now, this count equal to k only, count equal to k 0. I have 0, then I have to subtract k. Okay, 0 4 minus 1 is 3, 4 minus 1 plus 1 1. How many ones are there? Because I can include all this that formats, because I can include this 0 1. I can include these 3. I can include this area, because you can see the answer. If I mod this, I can include this one. I can include this. I can include this. The answer will be that for this index, answer will be plus 3. But I can take 3 subarrays from this index. From this also, I can take 2 subarrays, this one and this one. You can see the count of 1 is 2. From this, I can take only 1. From this, okay. That is the thing. Like I just have to just count the number of frequencies of current mode, and at last I have to include it on the answer. Like here I am counting the prefix sums like this. If this equal to k, I am calculating this and adding to the answer, and I am checking if there exists count minus k, like count minus k. Then I am taking the mod of, because it can be less than 0, so I'm making it greater than 0. m, I'm taking mod m because these are to just make it from 0 to m only. And at last, I'm including that count in the map. So this is the whole answer. I'm included 1 extra 0 because the answer can be, if we see here for the fastest conversion only 3 to 4. Okay, 3 to 4. The mod will be 1 0 0. For this one, there is one answer, but the map will not include any answer because the map will not include any answers because there is nothing before here, but there should be something because 0. If I type nothing, only this string, the answer should be this subarray should be included. So I have taken 1 0 extra, but to include that only one length subarrays. Uh, the code is pretty simple, but the logic is a little tough. It took me a lot of time to realize this. Okay, you just have to count minus. You have to check count minus k in the map. Previously, how many times it occurred, that and include it to the answer. That is the whole solution of the third question. I hope the solution is clear. Now moving on to the fourth question. In the fourth question, we are given a 3. We have to count the minimum number of operations to make the all numbers in the simple part from U to V this thing, not this thing, same. Like if I take from this part 0 to 3 part, there is all equal. If I take 0 to 4 part, the part from 0 to 4, there are 3 ones, 1 2. So I'll just change this 2 to 1. The answer will be the whole like whole edge, the weight in the whole part will be same. So the question is, how many numbers I should change to make the weights of the whole like, whole part equal? Like for let's see for this, if I take from the simple part from 5 to 3, I just have to, this change is 3 and this 4 to 6 is 3 to 6 and this 4 to 6. I can also change this 3 to 6, 6 to 3 and this 4 to 3. Then operations will be now 2 because I just have to make change 2 of this. Okay, let's simplify the question. Find out, like I have given an array of numbers for like 4 5 5 5 6. How many operations are required to make this array equal? I can change any number to any number. What I can do in this question, I will just change this 5 to 5. Okay, 5 5 5 5. The number of operations took is okay, 4. For again, I can change this 3, the whole array to 3, and then 3 3 3 3. The number of operations took is 5. I can change this to 4 also. That number of operations will be 5 only. I can change this to number of operations will be 4. One thing you can notice, if I change the whole array to the number which occurs maximum times, the operations will be minimum, because I just have to, if I change this array to 6, I just have to change these 4 characters only. But if I change this to 5, I have to change these 2 and these 3 characters. The answer will be like 5, the operations will be 5. But if I change it to 6, the operations will be 4. If I like have 6 6 6, I will change this 4 only, because if I take this 6, the answer will be maximum only. So I just have to take the maximum frequency, like I have to change the array to the element that occurs maximum number of times. Okay, then now if we somehow get the if we somehow get the array in the simple part, frequency of the elements in the simple part of uh, u and v, I can calculate the answer. Okay, like there are 3 occurs on, 6 occurs on, 4 occurs on. If I get the frequency of all the numbers, I can just take the maximum frequency, like take the elements, whole number of elements in the whole array, like here, whole array, there are 10 elements. 10 minus the operations will be this frequency of the maximum index, like operations will be 1 to 6. The operations will be 4. 10 minus 6 is 4. So I'll take the maximum frequency, I'll just subtract it. That will be the answer. Or I'll sum the minimum indexes only. Like ignoring the maximum frequency, I'll just sum 2 plus 1 plus 1. That will be the answer to 4. Like I just have to if I take sum, I just have to include a maximum frequency, because I'll not include that in the operation, because I'm changing the whole array to this 6 element only. If I somehow get the frequencies, because here 6 occurs 6 times, 5 occurs 2 times, 4 occurs once, 3 occurs once. Fine. Now I'll just change these 3 elements to 6 only. So I just add for changing this 5 to 6, there will be 2 operations, 1 operation and 4 operations. I'll just sum those elements, which has like lower number of frequencies. Now, how we can get the frequency count in that simple part? Okay, let's root the 3 somewhere. For this question, let's root the 3 in 0. Sorry, 1 in 1. I can root the 3 1. Okay, now let's take the simple part from 5 to 4. 5 to 4. Here 3 occurs on, 6 occurs on. Okay. Now, how can you count the frequency? If I root the 3 1, I can see here is 6, like in this part, one part from 1 to 4, 1 4, 6 occurs twice, and 1 to 5, 6 occurs once, 3 occurs once. Now, if I subtract an occurrence of 6 from both the part, I'm getting this occurrence of 6 and 3, like and I sum this occurrence occurrence of numbers in this part and this part, and subtract this part, and I'm getting this part. I'm adding this part, and I'm subtracting this twice from both the arrays. Like I'm taking this part, I'm subtracting this part, I'm taking this part, I'm subtracting this part, and I'm adding it. I'll get this like frequencies in this part. Like if I see here, I'm taking the frequencies of this part. I'm taking the frequencies of this part. I'll subtract this part. I can get this whole the number of frequencies in this part, because this contains the frequency of numbers in this part, and this contains the frequency of numbers in this part. If I subtract this one and add this two, I'll get the frequencies in this part, in part 6 to 7. Okay, fine. I hope you understood this. Okay, let's look at it again. Look at it again. What I have told. Okay. If I know all the frequencies in this part, I subtract the frequencies in this part, I can get the frequencies in this part. That is simple. I can find out the frequencies in this part. I can subtract this part because 3 is rooted in 1 root. I can subtract this part, I'll get this part. And I can get this part. If I sum these two frequencies in this two part, then I'll get the frequencies in this two part. In this simple from 6 to 7. Yeah. So the thing is, I'll just subtract the there is a the concept called lowest common ancestor. The lowest common ancestor of 6 of 7 is 3. I'll calculate all the frequencies of the like part of 1 to 6. I'll calculate the frequencies in the part of 1 to 7. I'll subtract the frequencies in the part of 1 to LCA. Then always get this frequency. I hope you understand. So that is what I have implemented also in the solution. Like for each node, I have stored the frequencies from root to that node. I can do that as in a DFS. I can take a count array. Here I have taken a count array. I've taken all the frequencies of the weights, and I've stored that count in every array, every node. Okay, I've stored the frequency of 1 to 3 from 1 to 3. I've stored from 1 to 0. I've stored from 1 to 7. I've stored from 1 to 6. I've stored from 1 to 7 to 1 to 5, and so on, so on. Now, if I subtract, like if I these are to calculate LCA at the last, you can see I am adding the like frequency of first node. I am adding the frequency of second node. I am subtracting the frequency of the LCA from the both nodes, and in that way I can get the frequency from U to in the simple part of U to V. And every time I'm like for each queries I am doing that. I'm taking the like calculating the factor like frequency vector, and I'm sorting the frequency vector like in greater, and I am ignoring the zeroth because I'll not include that in the answer because I'm converting the whole answer into that index that element only, and I'm taking the sum and adding it to the answer. So this is the whole solution. I hope it is clear.